Hello everyone, my name is Nena and I'm from the Pudhi Academy. So today we'll start with a new chapter, that is redox reactions. So redox, basically it is two types of reaction, that is reduction and oxidation. Since it is called redox, means both the reaction it takes place simultaneously. Now what is reduction? Reduction basically, in simple words you can say it is gain of electrons, and oxidation is loss of electrons. Okay. Now in reduction, in your lower classes you might have learned that in reduction we lose oxygen whereas we gain hydrogen. It's just a term, we gain hydrogen. It's not necessary that every time we should gain hydrogen or lose oxygen, okay? But in lower classes we have learned this, that reduction is loss of oxygen whereas oxidation is gain of oxygen. Or in terms of hydrogen you have learned that reduction is gain of hydrogen whereas oxidation is loss of hydrogen. Since I already told you, both can occur simultaneously. For example, here we have a reaction in which copper oxide is reacted with carbon. Here what happens? Copper oxide is reduced to copper. Here loss of oxygen is taking place, whereas carbon, it gains an oxygen and is oxidized. Okay, so since both of them takes place simultaneously, this is called as redox reaction. Now in this chapter, in today's video, what basically we will see is the basic idea of redox reaction, that is what is reduction and what is oxidation reactions. Redox reactions in terms of electron transfer reactions and competitive electron transfer reactions. So let's start. So chemistry, it deals with varieties of matter and changes of one kind of matter to other, right? So the transformation matter from one kind to another, okay, occurs through the various types of reaction. In your 10th standard, you have learned various types of reaction. For example, combination, decomposition, displacement, double displacement. Now all these kind of reactions, they involve conversion of one form of matter into another. Now one important category of such reactions is redox reactions. So a number of phenomena, both physical as well as biological, are concerned with redox reactions. Okay, in a normal human being also there is a kind of redox reaction that takes place. So it is not only sorry, it is not only a physical phenomena, it is also a biological phenomena. Now the reaction find extensive use in pharmaceutical, biological industries, metallurgical and agricultural areas. So it has a vast importance in all these fields: pharmaceutical, biological, industrial, metallurgical, agricultural areas and all. The importance of this reaction is apparent from the fact that burning of different types of fuels for obtaining energy for domestic, transport and other commercial purposes, electrochemical processes for extraction of highly reactive metals and non-metals, manufacture of chemical compounds like caustic soda, operations of dry and wet batteries, and corrosion of metals fall within the purview of redox processes. Now what does this redox reaction consist of? The importance of this reaction is everywhere, you can see. Burning of different types of fuels, the fuels that we use, for example petrol, diesel, your normal LPG. Burning of all these fuels, there is a redox reaction that is involved. For transport and for commercial purposes also. For electrochemical processes means for extraction of highly reactive metals and non-metals, to distinguish and to extract metals and non-metals. For batteries, dry and wet batteries. Regarding batteries and electrochemical purposes, you will learn in your 12th standard the chapter electrochemical series or electrochemistry. There you will learn the importance of redox reaction in batteries, their operations. Okay, so in all these factors the redox reactions are involved. Environmental issues like hydrogen economy, use of liquid hydrogen as a fuel, and development of ozone hole have started figuring under redox phenomena. Now all this ozone hole that is formed, it is also a phenomena with respect to your redox reactions. Okay, now classical idea or basic idea of redox reaction. Now what is oxidation and reduction reaction? Originally, the term oxidation was used to describe the addition of oxygen to an element or a compound. So initially, oxidation, this term was used to define addition of oxygen. Whenever there is an addition of oxygen, it is said to be oxidation. Now, because of the presence of dioxygen in the atmosphere, many elements combine with it, and this is the principal reason why they commonly occur on the earth in the form of their oxides. So, in the atmosphere, there is presence of dioxygen. Dioxygen means O2, okay, or approximately 20%. So many elements, they combine with this dioxygen, and this is the principal reason why they commonly occur in the form of oxides on the earth. Okay, basically why there is oxide present is because of the presence of dioxygen, and they combine almost with all of the elements. Now the following reaction represents oxidation process according to limited definition of oxidation. Now this reaction represents the oxidation process. For example, this is the basic reaction where we use magnesium. Okay, in 10th standard you might have used an experiment of burning of magnesium ribbon, right? When you burn a magnesium ribbon, it combines with oxygen to form magnesium oxide. Okay, so this reaction is what we do in general, right? So you have done this experiment where we burn a magnesium ribbon. When we burn a magnesium ribbon, it combines with oxygen to form magnesium oxide. Now again, sulfur is a metal. So when sulfur combines with oxygen, we get sulfur dioxide. So these are a type of oxidation reactions. Now in reactions, the elements magnesium and sulfur are oxidized on account of addition of oxygen to them. Here what happens, magnesium and sulfur, okay, both these elements, they are oxidized with the help of oxygens, okay, on the account of addition of oxygen to them. Now similarly, methane is oxidized owing to the addition of oxygen to it. Now methane is CH4. Methane, ethane, propane, these are alkanes. So when there is a methane and when it combines with oxygen, what happens is the oxygen will combine with both carbon and hydrogen, forming carbon dioxide and water molecules. Now, a careful examination of reaction in which hydrogen has been replaced by oxygen prompted chemists to reinterpret oxidation in terms of removal of hydrogen from it, and therefore the scope of term oxidation was broadened to include the removal of hydrogen from a substance. Now initially when the video started, I told you कि oxidation, it is gain of oxygen and loss of hydrogen. Now why there is a term loss of hydrogen involved is basically because of this. Here what happens, when the carbon dioxide is formed from methane, here we removed the hydrogens and we added oxygen to it. So there is a removal of hydrogen which is involved. So this broadened the scope of term of oxidation. The term oxidation, it broadened the scope, including the removal of hydrogen for a substance, from a substance. Okay. Now the following illustration is another reaction where removal of hydrogen can be cited as an oxidation reaction. Here also you can see the removal of oxygen. So H2S gas, okay, when we react it with oxygen, what happens is this hydrogen is removed from H2S and is combined with oxygen to form water molecules. So again there is a removal of hydrogen. Okay. Now as knowledge of chemist grew, it was natural to extend the term oxidation for reactions similar to which do not involve oxygen but other electronegative elements. Okay, so as the chemist grew, we discover more and more things. So it is natural to extend the term oxidation for reactions similar to which do not involve oxygen but other electronegative elements. So eventually oxidation term initially it was started with the addition of oxygen, then it came to removal of hydrogen, and at a point it came where there is no oxygen involved. Still we call it oxidation reaction. For example, involving a electronegative element. For example, oxidation of magnesium with fluorine. When we oxidize magnesium with fluorine, here you can see both the molecules, they doesn't have oxygen involved with them. There is a magnesium and fluorine. Okay, so magnesium when we combine with fluorine, it becomes MgF2. Okay, again magnesium when we combine with chlorine, it becomes MgCl2. So here electrons are involved. Okay, so basically oxidation started from the addition term, which was started from the addition of oxygen. It broadened its horizon with removal of hydrogen, and then at the end it is now involved in electronegative elements. Okay, so where there is no reference with oxygen or neither with hydrogen. So incorporating the reactions here from 7.5 to 7.7 within the fold of oxidation reaction encouraged chemists to consider not only the removal of hydrogen as oxidation, but also the removal of electropositive elements as oxidation. So these reactions put forth a concept where we have to consider that not only removal of hydrogen is oxidation, but also removal of electropositive elements is oxidation. Okay, now thus a reaction that is K4FeCN6 plus H2O H2O2 gives K3FeCN6 plus 2KOH. Here 1 potassium is removed and combined with potassium hydroxide is interpreted as oxidation due to the removal of electropositive element potassium from potassium ferrocyanide before it changes to potassium ferricyanide. So now you can see this reaction, it involves removal of one potassium molecule, that is initially it was K4. When it was K4, the term given to this molecule was potassium ferrocyanide before it changed to potassium ferricyanide. Okay, where one of the potassium molecule is removed. From K4 it became K3. Okay, so it is a conversion of electropositive, or it is removal of an electropositive element. Okay, so this is also considered as oxidation reaction. So to summarize the term oxidation, it is defined as the addition of oxygen, electronegative element to a substance, or removal of hydrogen, electropositive element from a substance. So in short, by including all the following factors, we can define oxidation as addition of oxygen or electronegative element to a substance. Okay, it can be either addition of oxygen or electronegative element to a substance, or removal of hydrogen or electropositive element from a substance. So oxidation is defined as addition of oxygen or electronegative element, or removal of hydrogen or electropositive element. Now in the beginning, reduction was considered as removal of oxygen from a compound. However, the term reduction has been broadened these days to include, now just like how we broadened the term oxidation, similarly reduction was considered to be removal of oxygen from a compound, right? Since oxidation is addition of oxygen, reduction was considered removal of oxygen, but the term reduction was broadened these days to include removal of oxygen or electronegative element from a substance, or addition of hydrogen or electropositive element to a substance. It is straight opposite to the term oxidation. Okay, if you learn the definition of oxidation, that is addition of oxygen or electronegative element from to a substance, or removal of hydrogen or electropositive element from a substance. Okay, straight opposite to that is what reduction is. Okay, now according to the definition given above, the following are the examples of reduction process. Here you can see oxygen is involved. So here oxygen is removed from mercury. So here it is removal of oxygen from mercuric oxide is involved. So first point is correct, removal of oxygen. Now next one is removal of electronegative element. Now FeCl3 is ferric trichloride, right? Here from this FeCl3, one chlorine molecule is removed and combined with hydrogen. So from FeCl3 it has become FeCl2. Since Cl is an electronegative element, it is removal of electronegative element, that is chlorine from ferric chloride. So again removal of oxygen and removal of electronegative element as per definition both are done. Now next one is addition of hydrogen. Here you can see CH2. This is ethene, right? To ethene I have added two hydrogen molecules and made it ethane. So this is addition of hydrogen. Again this is a kind of reduction. You have reduced double bond to single bond. Okay, so addition of hydrogen. Now HgCl2 plus SnCl2 gives Hg2Cl2 and SnCl4. Addition of mercury to mercuric chloride. Here you are adding an electropositive element. Initially there was only one mercury, but as the reaction processed there are two mercuries. So it is addition of a mercury to mercuric chloride. So all the four criteria is followed. Removal of oxygen and removal of electronegative element from the substances is followed. Again addition of hydrogen and addition of electropositive molecules which are involved. So this is what reduction is. Now in reaction, simultaneous oxidation of stannous chloride to stannic chloride is also occurring because of the addition of electronegative element chlorine to it. It was soon realized that oxidation and reduction always occurs simultaneously. Now in the last reaction you can see there is addition of electropositive molecules, right? Mercury is added, but the second compound, that is stannous chloride, here you can see it is SnCl2 which is converted to SnCl4. Addition of two more electronegative molecules are involved. So in a reaction it is seen that if there is a reduction taking place, there is oxidation also taking place simultaneously. So hence the word redox was involved. Redox means reduction and oxidation. It was coined from a class of chemical reaction, okay, where both oxidation and reduction takes place simultaneously. Now redox reaction in terms of electron transfer reactions. Now, we have already learned that the reactions, that is sodium and chlorine, it gives you sodium chloride. Sodium and oxygen gives you sodium oxide, monoxide. Then we have disodium sulfide. Okay, are redox reactions because one involves addition of electronegative element, other involved addition of oxygen, the next one involved addition of sulfur. Now these are all redox reaction because in each of this reaction sodium is oxidized due to addition of either oxygen or electronegative element to sodium. Simultaneously chlorine, oxygen and sulfur are reduced because to each of this the electropositive element sodium has been added. Now these three are redox reactions. Why they are redox reaction? Here chlorine, oxygen and sulfur, okay, all these three molecules are reduced. Why they are reduced? They are reduced because there is an addition of electropositive molecule to them, that is sodium. Since sodium is electropositive and it is added to all three molecules, it is said to be reduced. Whereas sodium in all these three cases it is oxidized. Why it is oxidized? Because chlorine, oxygen and sulfur, they are electronegative and oxygen is involved. So here sodium is oxidized. So sodium is oxidized and the other molecule associated with it is reduced. So this is our redox reactions. Now, from our knowledge of chemical bonding, we also know that sodium chloride, sodium oxide and sodium sulfide are ionic compounds, right? All of them, when we separate it, they give us ions. For example, Na plus Cl minus, right? We get different ions. Now, development of charges on species produced suggests us to rewrite the reaction. Okay, if we write them in the form, to rewrite them, for example, sodium, okay, sodium loses 2 electrons, whereas chlorine gains 2 electrons. So this is a kind of redox reaction. You are losing electrons and you are gaining electrons. As I told you initially, loss of electrons is oxidation, whereas gain of electrons is reduction. So here sodium is oxidized, whereas chlorine is reduced. Okay, so similar for other molecules, all of them are losing 2 electrons and gaining 2 electrons. So for convenience, each of the above processes can be considered as 2 separate steps. Okay, one involving loss of electrons and other gain of electrons. Now, as an illustration, we may further elaborate one of these, say the formation of sodium chloride. Okay, each of the above steps is called a half reaction. Okay, each of them are called half reaction. Half reaction means sodium losing 2 electrons to become 2Na plus. This is a half reaction of oxidation, whereas Cl2 gaining of 2 electrons and becoming Cl minus, this is another half reaction of reduction. So there are 2 reactions involved, okay, which explicitly shows involvement of electrons. Sum of half reactions gives the overall reaction, that is sodium, 2 sodium and Cl2 giving 2 Na plus and Cl minus, or 2 NaCl. Now suggests that half reaction that involve loss of electrons are called oxidation reaction. Similarly, the half reaction that involves gain of electrons are called reduction reactions. So as I told you earlier, the ones which are gaining electrons are called oxidation reactions, and then ones which are losing electrons are called reduction reactions. It may not be out of contest to mention here that the new way of defining oxidation and reduction has been achieved only by establishing a correlation between the behavior of species as per the classical idea and an interplay in electron transfer change. So a new way of defining oxidation and reduction has been achieved by establishing a correlation between behavior of species as per their interplay of electron transfer charge change, because one is losing 2 electrons, other one is gaining 2 electrons. So there is a transfer of electrons which are involved. So a new definition was arised because of this. Now, in reaction, sodium which is oxidized acts as a reducing agent. Sodium being oxidized, it acts as a reducing agent because it donates electron to each of the elements interacting with it and thus helps reducing them. Why it is a reducing agent? Because it donates electrons to each element and when interacting with it and thus helping them to reduce. Okay. Now chlorine, oxygen and sulfur are reduced and act as oxidizing agents. The other molecules which are associated with sodium, that is chlorine, oxygen and sulfur, they are called as oxidizing agents because these accepts electrons from sodium. They accept electrons from sodium and they act as oxidizing agent. Now to summarize, we may mention that oxidation is loss of electrons by any species. Reduction is gain of electrons by any species. Okay. Now, what are oxidizing and reducing agents? Oxidizing agent, they are acceptors of electrons. Reducing agent, they are donors of electrons. Okay. Now, next is the Competitive electron transfer reactions. Okay, place a strip of metallic zinc in an aqueous solution of copper nitrate. Now, for about an hour, you may notice that the strip becomes coated with reddish metallic copper and the blue color of the solution disappears. Okay. Formation of Zn2 plus ions among the products can easily be judged when the blue color of the solution due to copper 2 plus has disappeared. Now, when we place a metallic zinc, okay, in an aqueous solution for an hour, okay, of a copper nitrate, copper, it basically has a blue color solution, right? So you may observe that the copper or the zinc strip, okay, it is reddish in color, okay, and the color of the solution disappears. The blue color of the solution which was there of copper, it disappears, and the reddish metallic copper, it is coated on the zinc strip. Okay, now formation of Zn2 plus ions among the products can easily be judged when the blue color of the solution due to copper 2 plus has disappeared. When the blue color solution of copper 2 plus disappears, it indicates the formation of Zn2 plus ion. If hydrogen sulfide gas is passed through the colorless solution containing Zn2 plus ion, appearance of white zinc sulfide ZnS can be seen on making the solution alkaline with ammonium. So to confirm the production of Zn2 plus ions, if we pass hydrogen sulfide gas in the solution, okay, in the colorless clear solution, you can see the formation of zinc sulfide, okay, can be seen on making the solution alkaline with ammonia. Okay, so the reaction between metallic zinc and the aqueous solution of copper nitrate is zinc sulfur. So this is the reaction what takes place in that beaker. Okay, so zinc is converted to zinc plus ions, whereas copper ions is converted to a copper. Now in reaction, zinc has lost electrons to form Zn plus ions. Here zinc has all its electrons, whereas when the product is formed, zinc has lost 2 of its electrons, whereas copper, it has lost 2 electrons. This copper gains the electrons which were lost by zinc and becomes copper. So now zinc is oxidized, releasing electrons. Something must be reduced accepting the electrons lost by zinc, right? So copper ion is reduced by gaining the electrons which are lost from the zinc. So in general, if we want to write this reaction, it will be Zn, okay, forming Zn2 plus by leaving 2 electrons, whereas copper 2 plus, it accepts the 2 electrons and becomes copper. Okay, so this is what basically happens in the reaction. Okay, here it is shown zinc, it releases 2 electrons, becomes Zn2 plus. Copper, it gains 2 electrons and becomes copper. Now at this stage, we may investigate the state of equilibrium for the reaction represented by equation. Okay, for this purpose, let us place a strip of metallic copper in a zinc sulfate solution. Now, no visible reaction is noticed and attempt to detect the presence of copper 2 plus ions by passing H2S gas through the solution to produce a black color of cupric sulfide CuS does not succeed. Now here we can make out the things because there is a difference in solution, right? The blue color has disappeared, and when we pass hydrogen sulfide gas, we can see the formation of white zinc sulfide, right? But when nothing is possible, okay, when you can't make out the difference by observing it, and by passing H2S gas also you can't make out the copper sulfide, it's not succeeded, then what happens? The cupric sulfide has such a low solubility that this is an extremely sensitive test. Okay, yet the amount of copper formed cannot be detected. Okay, we thus conclude that the state of equilibrium for the reaction greatly favors the product over the reactants. Okay, so we can conclude that the state of equilibrium for the reaction, okay, it greatly favors the products over the reactants. So let us extend electron transfer reaction now to copper metal and silver nitrate solution in water and arrange a setup as shown. So here this is the setup. Okay, now the solution develops a blue color due to the copper ions on account of their reaction. So whenever copper ions are involved, you get a blue color solution. So copper and silver, again same thing. Copper releases 2 electrons and becomes copper 2 plus, whereas silver, it gains 2 electrons and becomes silver. Okay, so here copper is oxidized to copper 2 plus ion and silver is reduced to, or silver ion is reduced to silver. So equilibrium greatly favors the products. Okay, because the ions which are released should be accepted by one molecule and should be stabilized. Now by the way contrast, let us compare the reactions, okay, of metallic cobalt placed in nickel sulfate solution. Again same thing happens. Cobalt, it releases 2 electrons and the electrons which are released by cobalt, okay, it is taken up by the nickel. Okay, so cobalt is converted to iron whereas nickel is converted to a metal. Okay, now at equilibrium, chemical tests reveal that both nickel and cobalt are present at moderate concentrations. In this case, neither the reactant nor the product are greatly favored. Okay, so when there is an equilibrium, the chemical tests reveal that both nickel and cobalt are present at moderate concentrations. Okay, this competition for release of electrons indecently reminds us the competition for release of protons amongst acids. Okay, so similarity suggests that we might develop a table in which metals and their ions are listed on the basis of their tendency to release electrons, just as we do in case of acids to indicate the strength of the acids. So we have to make a proper table and we have to arrange these ions in a form of their tendency to lose electrons or release electrons. Okay, and in that pattern we can, if we are conducting a reaction or we are carrying out a reaction, if we know the tendency of the elements which can release electrons and the tendency of element which can accept electrons, we can simultaneously select or choose appropriate metals atoms for the reactions. Now as a matter of fact, we have already made certain comparisons. By comparison, we have come to know that zinc releases electrons to copper and copper releases electrons to silver, and therefore the electron releasing tendency of the metals is in the order of zinc has greater tendency to release electrons than copper and then silver. Okay, so this is the trend how electron releasing tendency of metals are seen. Okay, we would love to make our list more vast. Okay, and design a metal activity series or electrochemical series. Okay, in electrochemical series there will be a full chart according to the tendency of electron releasing as well as the tendency of electron accepting. The competitions for electrons between various metals helps us design a class of cell named as galvanic cells. So initially when I was telling you all about the uses of redox reaction, I have told you all that redox reactions are seen in batteries and cells, right? So one of those battery is galvanic cell. About this galvanic cell you will be learning in detail in your 12th standard. Okay, so in today's video we have basically seen about the redox reaction, what is oxidation, what is reduction reaction, their definition. We have seen competitive electron transfer reactions. We have also seen redox reaction in terms of electron transfer reactions. what is the exact definition of oxidation and reduction, and on what basis the definitions were given. These are the things that we have seen for today's video. So thank you for watching my video. Please do like, share and subscribe to our channel.